right, hey everyone, welcome back to our just after midweek uh, lesson here. So we're looking at referent angles today and estimation. This lesson is going to be quite straightforward in terms of the material that needs to be presented here, and it won't take, it's going to take less than 10 minutes. So let's just look at what we're talking about here. So building off of our geometry lesson from before, we were looking at classifying angles, such as our 90-degree angles, our straight angles, our what else do we look at? Right angle, straight angle, obtuse angle, acute angle, reflex angle, all that stuff, right? This one we're looking at referent angles, and we're actually going to start looking at giving more exact numbers and values to angles. So it's good to have like this general kind of abstract idea of what an angle is. And now we're moving into from that abstract realm and maybe the less exact realm and moving into the more exact realm, which is always kind of a goal with math, is to take something that's kind of a general idea and put it into a more exact idea, right? So when we're looking at reference angles or referent angles, I'm just going to basically talk about whatever a reference angle is. And the reference angle, we use them a lot in higher level math in terms of trigonometry and geometry and other stuff. But for our purposes, we're just going to say that a reference angle or referent angle is any angle of known value that we can use to help calculate or estimate another angle or the angle itself, right? So, and this is used in many places, carpentry, uh, anything that would use a protractor or angle. So like architecture would be another good example. So in many jobs, people have to draw angles or estimate them to some degree. To estimate them, we can use a lot of known reference angles. And these are kind of like the big four that we usually work with and know about. So there's a 90-degree angle, which is the angle that your floor makes with your wall. There's a 45-degree angle, which you can think of, that's going to be half of what that 90-degree is on your wall. So think about if you took that 90-degree angle and you chopped it right in half, that's your 45-degree angle. So you can kind of see that. It's kind of going right in between a full 90 degrees here, right? Then we have a 30-degree and a 60-degree. These two are kind of offshoots. We can treat them as like the 30-degree is a little bit less than the 45, and the 60-degree is a little bit more than the 45, right? And so we're just going to use these to help estimate some basic angles. So let's look at some examples here. So we got this right here. Let's see if we can make this exactly. Oh, we can. Beautiful. So example, use the reference angles above. So these guys, all right here. To estimate the size of these angles, after estimating their size, use a protractor. I realize not a lot of you might have access to a protractor. For these questions, I don't mind, I don't really care about that. Let's just get our estimation skills up to par. We don't need to actually worry about measuring these exactly. Okay, so let's look at A here. So based off of our reference angles up here, what do you think we could estimate angle A to be? Can we say it's 90 degrees? No, right? Because this is much less than 90 degrees. We can see that. And it doesn't have that square there, so we can't say it's 90. Well, can we say it's 30? Probably not either, right? Because it looks like it's pretty big. It's bigger than 30. Can we say it's 45? Yeah, it might be a little bit close to 45. Can we say it's 60? Yeah, it could be 62. So how about we say, like, because we don't know if this is 45 exactly, we don't know if it's 60 exactly. How about we just say it's probably somewhere in between those, right? Let's just say that, let's estimate that angle A is about, actually let's draw it in the angle itself. Let's say it's about, I'm going to use squiggly equal signs, which means like about 50 degrees. Okay, I think that's a reasonable estimation. What about B? Well, B is definitely not this. It's definitely not this. It's definitely not this. So it's hovering around the 30 range, but it looks like it's like a little bit less than 30. Well, a reasonable estimate, I think we could say that this is probably about 20 degrees. A little less than 30 degrees, 20 degrees. And what about C here? What about C? Well, this one is definitely bigger than all of these, right? And if it's bigger than 90, then we know that we're going into an obtuse angle because we're getting bigger than 90 degrees. So we have to go to an obtuse angle. Well, what do we know? What was the angle if we just draw like a straight line here? That would be 180 degrees, right? Well, it's a little bit less than 180. Well, how about we say probably about 170 degrees? I think that's fair to say, 170. And so the way that we can actually label these, we can say that angle A equals, we can do a little squiggly on top of that, let's say 50 degrees. And this means angle. So angle B here, we could say it's about 20 degrees. And angle C, it's about, we're saying 170 degrees. So that's all we have today. I'm post some practice problems with this, and other than that, just have that complete by Friday, and we're off to the races. Okay. Hope everyone's week is going well and your classes are going swell. I will connect with you later on. Peace.